Our first homework problem asks, what is the resistance of a toaster if 120 volts produces a current of 4.2 amps? The first thing we want to do, as always, is identify our known values and identify our unknown value. Our two known values in this problem is the potential difference, which is 120 volts, and our current, which is 4.2 amps. We're being asked to find the resistance of the toaster. So if we're given the potential difference and the current, being asked to find the resistance, we're going to want to use Ohm's law, V equals IR. We want to solve for the resistance, so we want to isolate that. We're going to multiply both sides of Ohm's law by the current. We're going to get R equals V divided by I. We substitute in our known values, our voltage of 120 volts, our current of 4.2 amps. Do the algebra, and we should get a resistance of 29 ohms. Does this webcam make my head look fat? Oh, hey, sorry guys, I didn't know you were ready for the next problem. This problem states a hairdryer draws 7.5 amps when plugged into a 120 volt line. They want to know what the resistance of the line is and how much charge passes through the line in 15 minutes. Our known values are the current, 7.5 amps, and the potential difference, 120 volts. To find the resistance, we need to use Ohm's law, V equals IR. Solving Ohm's law for resistance gives us the voltage divided by the current. 120 volts divided by 7.5 amps will give us a resistance of 16 ohms. To find the charge passing through the line, we first need to convert our time value to seconds. We know there are 60 seconds in 1 minute, so 15 minutes equals 900 seconds. To find the charge, we need to use the definition of current. I equals Q divided by T. Current equals charge divided by time. Solving this equation for charge gives us Q equals I times T. Current times time. 7.5 amps times 900 seconds is going to give us a charge of 6.8 times 10 to the third coulombs. A 9-volt battery is connected to a bulb whose resistance is 1.6 ohms. How many electrons leave the battery per minute? How many electrons? How can we figure out how many electrons are leaving the battery? Well, what do we know about electrons? We know that electrons are charged particles, and we know that current is the rate at which charge flows. So if we could determine the current leaving the battery, then we could figure out how many electrons are leaving the battery. So to find the current, we need to use Ohm's law. We're given the voltage at 9 volts. We have the resistance at 1.6 ohms. We know the time factor is 1 minute. We'll need that in a little bit. And we're looking for the number of electrons. So using Ohm's law, V equals IR, solving that for I, we have I equals V over R, voltage over resistance. 9 volts divided by 1.6 ohms is going to give us 5.625 amps. Now remember, current is the rate at which charge flows, and 1 amp is equal to 1 coulomb per second. So an amp is equal to coulombs per second. So I can rewrite 5.625 amps as 5.625 coulombs per second. So I know the charge of 1 electron is 1.60 times 10 to the minus 19th coulombs. I can use that to convert between coulombs and electrons. And I know my time factor is 1 minute. There are 60 seconds in 1 minute, so that's another conversion factor. So using those two conversion factors, I can go from coulombs per second to electrons per minute. And I'm going to end up with 2.1 times 10 to the 21st electrons per minute. Problem number 4. An electric device draws 6.5 amps at 240 volts. There's two parts to this problem. The first part asks if the voltage drops by 15%, what would be the current, assuming that nothing else changes? And part B, if the resistance of the device were reduced by 15%, what current would be drawn at 240 volts? So first of all, my givens are the current, which is 6.5 amps, and the voltage, which is 240 volts. Now, if I look at Ohm's law, V equals IR, note that the voltage and the current are on opposite sides of the equal sign, which means that they are directly proportional to one another. So if my resistance is staying the same and I decrease my voltage by 15%, that means I'm going to have to also decrease my current by 15%. So decreasing by 15% is the same as multiplying by 0.85. So my final current is going to be equal to my initial current times 0.85. 0.85 times 6.5 amps is going to give me 5.5 amps. For the second part, if I'm dropping the resistance by 15%, what happens to the current? Well, going back to Ohm's law, V equals IR, if I look at current and resistance, they're on the same side of the equal sign, which means that they're going to be inversely proportional to one another. If my voltage remains the same and I decrease my resistance, that means my current needs to increase. So if I'm going to increase my current by 15%, it's going to be the same as dividing by 0.85. So my final current is going to be my initial current, 6.5 amps, divided by 0.85, which will give me a final current of 7.6 amps. Problem number 5. A bird stands on a DC electric transmission line carrying 2,800 amps. The line has 2.5 times 10 to the minus fifth ohms of resistance per meter, and the bird's feet are 4 centimeters apart. What is the potential difference between the bird's feet? Let's take a look at what we're given in this problem. We're given the current, which is 2,800 amps. We're given the resistance at 2.5 times 10 to the minus fifth ohms per meter. And the distance between the bird's feet is 4 centimeters, which we have to convert to meters. So that's 4.0 times 10 to the minus second meters. And we're looking for the potential difference between the bird's feet. In order to find the potential difference between the bird's feet, we need to know how much resistance there is within that same span of 4 centimeters. So to find the resistance between the bird's feet, we want to multiply our resistance per meter, 2.5 times 10 to the minus fifth ohms per meter, times the distance between the bird's feet in meters, 4.0 times 10 to the minus second meters. That gives us a resistance of 1.0 times 10 to the minus 6 ohms of resistance between the bird's feet. And now we know with that resistance, we can plug that into Ohm's law, V equals IR, and multiply the resistance between the bird's feet by the current of the line, 2,800 amps, and that's going to give us a voltage of 2.8 times 10 to the minus third volts.